integral that involves u substitution to evaluate the integral of x squared plus 3 square root of x plus 1. Now for this integral, we have several choices for u. We can set u to be the x squared plus 3 part. We can set u to be the square root of 2x plus 1 part, or we can set u to be 2x plus 1. So we have several options here. Now, it's not really easy to know which one is the one that's going to work. So the best answer here is to just try and see which one does work. By that, what I mean is whenever you use the substitution, if you end up with something more complex that you started with, that's probably not a good idea. So by that, we can figure out that the first two options are actually not the best strategy. For the third option, then we have that du equals 2dx. From here, we can actually use this information to translate our initial integral now in terms of u. So this is going to be the integral of, notice that this part right here becomes just the square root of u. Then dx from this equation down here is going to be just du over 2. And we're missing this part right here. Notice that this part doesn't look like anything that we have in our substitution list. But nonetheless, from this initial substitution, this part right here, we can actually solve for x. So from that part, we have that x is going to be u minus 1 divided by 2. So this is going to be useful in order to rewrite the original expression in terms of u. So that would give me then that the first part is going to become u minus 1 divided by 2 squared plus 3, and the whole thing divided by the square root of u. In other words, let me write it down again more clear. We have that the new expression looks like the integral of u minus 1 over 2 squared plus 3 times square root of u divided by 2 du. Now, at first sight, this expression would probably don't look better than the original one, but notice one little detail. In the first expression, we had a rather complex radical. We had the square root of these 2x plus 1, but now it looks much better because it's just the square root of u. So this expression is the most critical one. Even though the other expressions look a little bit more complex, this actually will be simplified and we can work with it. So what I'm going to do is I'm going to simplify this expression. I'm going to put the 1/2 in front of everything, and then I'm going to expand this square that we have over here. So that will give me then, inside of that parentheses, that will be u squared divided by 4, I'm sorry, minus 2 times u divided by 4 plus 1 over 4, then plus 3 times the square root of u du. So the only thing that I did over here was to work out this square that was right there. And notice that we're dividing everything by 2 squared. That's why we have 4s over there. So that is just working out u minus 1 squared divided by 2 squared, which is the one that gives me all those 4s. So now I can work it out. So this expression will then become 1/2 the integral of, we have u squared over 4. We have minus u divided by 2. We can cancel those numbers over there. And then we have a quarter plus 1/3. So I believe that would be 13 over 3. And we multiply this by the square root of u. So in order to simplify this a little bit more, let me go ahead and write down that square root of u as u to the 1/2. So I can have everything in terms of powers. That way it's a little bit more easy to work with this expression. So this will become the integral of, and it will be a quarter, u to the 5 over 2 multiplying this 1/2 with this square over here, minus 1/2 u to the 3/2, multiplying this 1/2 by this 1 right here. And then finally, I end up with plus 13 over 3 u to the 1/2. Now, the advantage of this expression is that every single term is just a power. So I can use the reverse power rule in order to get the final value for this. So this will become 1/2 in front of everybody. And this will be, the antiderivative for this part is 1/4 u to the 7 over 2 divided by 7 over 2 minus 1/2 u to the 5 over 2 divided by 5 over 2 plus 13 over 3 u to the 3 over 2 divided by 3 over 2 plus a constant. So notice that over there I just used the reverse power rule, which really meant to add 1 to the exponent and then divide by that number. And then the only thing that I need to do is to go back in terms of x. I already have my antiderivative over there. So let me try to rewrite this a little bit nicer. So I'll multiply the 1/2 in every single term that I have, and also work out the expression that I have down here. So this will become, the first term will become a 1 over 8, multiplying that 1/2 by the 1/4, times 2 over 7, u to the 7/2, minus 1/2 and 1/2, that'll become 1/4, times 2 divided by 5, u to the 5 over 2, plus 1/2 and 13 over 3, that becomes 13 over 6, times 2/3, u to the 3/2, plus constant. So if I simplify one more time, the fractions that I have, just let me try to put them together. The first one will become, this goes with the 2, so I have a 1/4, and this will be 1 over 28, u to the 7 over 2, minus the 2 and the 4 go away, so I'm left just with a 2 on the bottom, so that will be 1 over 10, u to the 5 over 2. And then the 2 and the 6 will cancel, and that will leave me just with a 3 downstairs, so that will be 13 over 9, u to the 3/2, plus a constant. And now I'm in pretty good position to go back to my original substitution, which is the one that I have up here. So remember, u was 2x plus 1, so I can go back in terms of x. U equals 2x plus 1. So then that means that this thing is going to be 1 over 28, 2x plus 1 to the 7/2, minus 1 over 10, 2x plus 1 to the 5/2, plus 13 over 9, 2x plus 1 to the 3/2 plus a constant. And that will be the answer for our question.